Welcome to Testimation Video Lesson 1, Part 2. In this video, I will be reviewing the estimation process undertaken in Part 1. You shall learn how to maximize the usefulness of the product suite and predict the probability of finding defects. Let's begin. After I have logged in, the first thing I must do is select the appropriate tool to use. To do this, I need to understand the information presented on the application landing page. On the application landing page, I am presented with a workflow diagram. The workflow diagram displays 25 possible functional processes. These 25 functional processes are derived from 5 use cases, or if you prefer agile terminology, 5 user stories. The 5 user stories are listed and accessible by clicking the question mark help icon in the workflow diagram title box, or by referring to the user instruction manual on the Testimation website. Each user story has its own specialty, so in order to select the correct one to execute, we need to first understand what information we have available to us. In this video lesson, we are simulating the estimation process if we were to build this application from scratch. In such a case, all we know from the project sponsor is that the final product will have 25 functional processes. We really do not know more than this, but in fact, that is enough. Since this product suite will be new to the marketplace, we do not have a similar previous project to use as a guide. We have professional experience, but we do not have a known solution to use as a baseline. However, what we do have is hard science available to us, to help us make predictions. Consequently, we conclude that the most appropriate user story to reach for is the Type 1 testimator. The Type 1 testimator has 4 possible user interfaces. Let's assume that we want a quick estimate with a 99% confidence that we will find defects. Therefore, we select the Questimate user interface. Now that the user interface has been decided, we need to select the type of input we wish to use. We have the choice of working in terms of functional processes, use cases, user stories or test scenarios. We shall select functional processes, but we could have easily worked in terms of any of the other 3 input types. Recalling that we have 25 functional processes as a requirement from the project sponsor, we adjust the slider until we achieve the correct value. Next, we click the configuration button to reveal 2 input dials. When functional processes are selected as the input type, the conversion ratio dial is inaccessible, so we do not need to worry about it. What we do need to consider is the DITS per test case input value. DITS is an acronym for Dynamic Information Tests, and represents any data field on the screen which can change. The average number of DITS that we can expect to check per test becomes known as the number of DITS per test case. A test case is a series of steps that the user must execute to verify the outcome they expect. The default value of DITS per test case is 10, and we know from experience and years of actual measurements that 10 is a fairly universally applicable setting. If you are unsure in any way, just use the default value. However, across very large populations of tests, such as you might find in a big corporation, the value of DITS per test case may be as low as approximately 3. With the scope known and the configuration set, we are ready to review the results. By expanding the risk management and estimates sections, important information is displayed. The risk exposure indicator, as the name suggests, displays the percentage impact that our project of 25 functional processes would have upon a larger system if it were fully integrated with it. By contrast, the risk mitigation indicator displays the probability of finding at least one defect based upon the quality assurance strategy we have designed. The probability of finding defects is a key feature in this application suite, which we can control by selecting the Advanced View user interface. However, the default probability in the Questimate view is 99%. This is one reason why Questimate is an acronym for Quick Estimate, whereby an estimate with high probability of finding defects can be generated very quickly. That is, we let science do the thinking for us. The Estimates section displays how much we need to test, in order to be 99% confident that we will find defects. Of particular importance is the calculated value of DITS, which is an acronym for Dynamic Information Tests. The number of DITs is a scientific calculation. It is not based upon experience or perception. It represents the maximum number of dynamic information tests which may need to be executed to be 99% confident that the application suite is free from defects if it were fully integrated into a larger system. A dynamic information test is a check for compliance of any dynamic data field displayed on the screen. For example, each dial indicator you see involves 3 dynamic information tests: color, graphical compliance, and calculated value. These are 3 distinct tests because they are 3 separately controlled dynamic properties and must be manipulated during the development process. Therefore, we may interpret the calculated value of DITs to mean that there is a 99% probability that the application will contain the value of DITs displayed when the application suite is completely finished development. The number of test cases is simply a representation of the average number of DITs combined into a single test. It would be very uncommon for each potential DIT to be validated one by one. It would not be a very efficient way for people to work. Typically, multiple dynamic information fields will be checked for compliance in a single test, termed a test case. The regression testing section has 2 categories. That is, manual and automated test suites. The manual regression suite value displays a subset of test cases required to be executed from the total number, in order to be 99% confident that all of the test cases would pass if they were executed. In principle, the subset should be randomly selected, but the reality is that the number of possible combinations of test cases is so vast, that any combination is acceptable. Therefore, as testing professionals, we would expect to select the most appropriate test cases to be included in the regression suite. We would not be required to randomly select a new combination each time we wish to rerun the regression suite. The automated regression tests are a statistical subset of the manual regression suite, such that, if the number of test cases calculated were executed and passed, we could be 99% confident that all of the manual regression test cases would pass if they were executed. By taking this approach, we are ensuring that we maximize quality assurance while minimizing cost, and we have the additional advantage of standardizing on a quality assurance strategy which does not vary from project to project. Let's now take a look at the next tool in the product suite. This tool is called the Estimator, an acronym for Alternative Estimator. Using this screen, we can assess an alternative estimate and compare it to our own prediction, which we have just completed, and appears in the left half of the screen. By entering the number of test cases obtained from an alternative source, we can compare strategies to determine if the alternative estimate is an acceptable solution. The more test cases designed and executed, the greater the cost of quality assurance and therefore, the greater the probability of finding defects. Similarly, the lower the number of test cases, the lower the cost of quality assurance, but also a lower probability of finding defects. In this example, we see that the alternative estimate involves a significantly different targeting distribution, as shown by the black line. This particular distribution means that the alternative estimate focuses primarily on critical priority tests, while our own prediction considers critical, high, moderate and low priority tests. But remember, with a reduced estimate, comes a lower probability of finding defects. This tool is called the Restimator, an acronym for Regression Estimator. If we assume that this product suite were integrated into a larger system with many touch points, we can use this tool to calculate the required statistical subset of test cases from an existing repository. To minimize the number of test cases, we can select from 3 levels of confidence. A graph of the sampling distribution is also displayed. With this information, we are able to formulate an overall quality assurance estimate from a project management perspective. This is the final screen in the estimation process. Here, a user enters working capacity information and resourcing levels to obtain the overall project quality assurance solution.